Hello, welcome back to another video. We're looking at the last lesson of Unit 6. That's Lesson 6.6. Let's jump right into the notes. Let's make this short, sweet, to the point. So today's lesson is pretty similar to 6.5. We're going to have to label opposite, adjacent, hypotenuse, and use trig functions. But instead of solving for sides, we're going to solve for angles, which is kind of cool. So let's remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's read this blurb together here. We know that we can use trig functions to solve for missing sides. But wait, there's more. Trig functions can also be used to solve for angles. Yes, I know, terrific. To find a missing angle, we use inverse trig functions. And the word inverse essentially means reverse or backwards. So we use trig functions that are in the reverse, which will make more sense here later on. And they look like that. That's what they look like. So, opposite, adjacent, and hypotenuse, right? Well, first mark the angle and then label the sides, step 2. Decide which trig function to use based on those sides. We've done that before. We're going to set up a similar equation. We've done that before. But instead, we're going to take the inverse and we use our calculator to solve. So lots of similar steps, except we're using inverse trig functions. So let's dive right into it. Let's say we want to solve for angle A. All right, mark your angle. Here is angle A. All right, let's label our guys here. Let's label our guys. This right here is the opposite. This right here is the adjacent, and this right here is the hypotenuse. Right, opposite, adjacent, hypotenuse. So I know all three sides. So which trig function do I use? It doesn't matter. So let's use sine. Sine is opposite over hypotenuse. So sine of A is opposite over hypotenuse. Okay, that's great and all, but what is A? Well, introducing the inverse function. We inverse 5 over 13, and that solves for angle A. Okay, that's what our steps are saying here. Decide which trig function to use, set up the equation, and then take the inverse. Beautiful, right? And we just plug that into a calculator. So this, make sure you're in degree mode. And then if you click the inverse button on the Google calculator, it gives you these guys. So if we inverse 5 over 13, we get 22.6. And in our directions, it doesn't say how to solve. So let's just round to the 10th place, 22.6 degrees. 22.6 degrees, okay? Now, how do we solve for angle B? Well, tell me, how many degrees are in a triangle? 180, right? So, if we know that one of them is already 90 and the other one is 22.6, just do this, right? Get rid of the other two angles and whatever's left is your third angle. So 180 minus the 90 degree angle minus the angle that we just found, and we're left with the third and final angle, 67.4 degrees. I highly recommend that you do it that way instead of trying to use a trig function again, right? Just subtract from 180. So sine. And like I said, but you might have missed that I said it, it doesn't matter which one I use. Let me prove a point. What if you said, oh, well, I know cosine. Cosine of angle A is 12 over 13. You're right, it is. And if you were to inverse this to solve for angle A, and inverse just means reverse, right? So I already know the value of cosine. I want to reverse that to solve for the angle. So I inverse it. And check this out. If I type that into a calculator, inverse cosine of 12 over 13, again making sure I'm in radians mode, or sorry, degree mode and not in radian mode, inverse cosine of 12 over 13 over divided by 13 is 22.6. The exact same thing. We get the exact same answer. It does not matter which trig function you use if you know all three sides. Okay? So do not stress about that. Let's set it up again. I want to know the value of angle A. This time, my options are limited. I only know two sides out of the three. So I'm kind of forced to use which function? Well, this is the hypotenuse because that arrow points towards it. And boom, this is the adjacent. I'm kind of forced to use cosine. Cosine of A is adjacent, 8 over hypotenuse, 10. I know the value of cosine, but if I inverse that, that solves for my angle, which is what I want. Again, inverse is reverse, okay? So in our previous lesson, right, if I were to go back to those notes, right, in our previous lesson, we knew the angle and we were solving for a side. We're going the opposite direction. We know the sides and we want to know the angle, which is why we have to use the inverse trig function because it goes in reverse. All right. So you plug this into a calculator and you get your answer. Inverse cosine of 8 over 10 is 36 point, round that up to 9, 36.9. So if A is 36.9, again, use the same strategy. 180 minus 90 minus 36.9. If you subtract the other two angles, it gives you the third. And I get 53.1 degrees. All right, let's have our first question. All right, I'm going to label these for you, and then you tell me which trig function we're going to use. If I'm trying to solve for t, I know that 7 is the opposite, and I know that 4 is the adjacent. What trig function am I going to use? All right, so you just told me which trig function I'm going to use. Opposite and adjacent means tangent. SOHCAHTOA. It means tangent. So tangent of t is opposite over adjacent. If we inverse that, we solve for the angle. I guess I should use a capital T. We solve for the angle. Making sure you're in degree mode. And we use, and we use the inverse button to bring these guys up. Inverse tangent of 7 over 4 is 60.3. And hopefully you remember what you're supposed to do to find the third angle. What is the third angle? You just solved for the third angle and you remembered that 180 minus 60.3 minus 90. If you subtract the other two angles in the triangle, we already know 2, it leaves you with the third. And when you plug that in, you get 29.7 degrees. Lovely. It really is. So there's a whole bunch more here. I'm not sure how many we really need to do. We're under 10 minutes. So we're going to try to keep the video at like, under maybe 50, under 20, maybe like 15, 16. So let's keep it moving. Here's the angle. If you know all three sides, the world is your oyster. Use whichever trig function you'd like to use. My personal favorite is sine, just because it comes first on the calculator, and it comes first in SOHCAHTOA, right? So there's the opposite, there's the hypotenuse. So sine of the angle is 33 over 65. So I inverse that to solve for the angle. It really is that quick. If I'm going too fast, or you don't know how I came up with that, go back to the beginning of the video if you need to, right? And hear what I had to say again. I get 30.5 when I inverse that. I'll try to explain the next one again one more time, right? I label here. I don't know all three sides, right? It looks like I did, but it looks like I got cut off, so we're going to ignore that. Just use what you're given. I know that this is the opposite side. I know that this is the adjacent side. So katoa. Well, I'm forced to use tangent because I know the opposite and I know the adjacent. So tangent of the angle is opposite over adjacent. Boom. So what do? I use the inverse function to solve for the angle. And I end up getting what? Inverse tangent of 72 divided by 54 is 53.1. It really is that quick. Oh, these are interesting. I was going to ask you a question about these, but honestly, I want to talk about these. Well, here, how about this? Here's a question. What type of triangle is this? What type of triangle is this? There's a couple of options that should make sense to you on the screen. Boom. What'd you choose? Hopefully you said it's a 45, 45, 90 triangle. How do we know that? Because, well, if the leg is 40 and the hypotenuse is 40 root 2, it's following the pattern. It's following the pattern of k, and k root 2. Boom. So how big are these angles then? 45 degrees. Boom. Who needs trig functions? Right? Who needs trig functions? All right. Here, this one is not following a pattern. So I'm going to have a multiple choice option on the screen. You just go ahead and solve it for yourself. And you can use sine, cosine, or tangent because you know all three sides. So go ahead and solve this for yourself. Boom, there's a few options on the screen for you. So which one did you choose? I don't know which one you chose, but like I said earlier, I like sine, but I'll switch it up and use cosine. This side is the adjacent. This side is the hypotenuse. Cosine of the angle, who knows what it is, we'll figure it out in a second, is adjacent over hypotenuse. To solve for the angle, you inverse, and voila, you get your answer. One more time, going into the calculator, inverse cosine of 30 divided by 78 is 67.4 degrees. That 8 rounds that 3 up. All right, let's knock out a few word problems and we're done. How many are there? There's 3. Maybe we only do 2, but let's see what happens. Here we go. A dog is standing 5 feet from the base of a tree looking up at a cat. So this is explaining what angle of elevation is. Angle of elevation is the idea of looking up to an object, okay? A dog is standing 5 feet from the base of a tree. So here's our tree going straight up and down, and the dog is standing 5 feet away from that tree. So 5 feet away is the dog looking up at a cat. Looking up at a cat, okay? That has climbed 16 feet up the tree. What is the angle of elevation from the point of the dog, from the point the dog is standing on the ground to the cat? That was a weird sentence to say. What is the angle of elevation from the point the dog is standing on the ground to the cat? I feel like there's like a weird phrasing there. But what is the angle of elevation from the dog up to the cat? Right? That's what we're looking to find. We need to know that angle. I forgot to label the 5. Boom. So the dog standing, this is not drawn to scale, clearly. The dog standing 5 feet from the tree, and the tree itself, or where the cat is in the tree, is 16 feet high. So we solve for the angle. And tell me, question right here. What trig function are we going to use to solve for the angle? Inverse sine, cosine, or tangent? Hopefully you look at this offhand and you're like, oh, that's O and A. I'm going to use inverse tangent. So if tangent of the angle is 16 over 5, you simply inverse that to solve for the angle. So how high up is the dog looking? Let's figure it out. He's looking up 72.6 degrees. So he's looking up pretty high. That cat is... because he's so close to the tree, right? That ought to make sense. If I'm only 5 feet from a tree, that tree, I'm going to be looking practically straight up at it. The further away I am from the tree, the less I have to look up to see the object, right? That ought to make sense. When looking down to an object, that's called the angle of depression. All right? So depressed meaning you're down, okay? So we're looking down. A lifeguard is sitting on a platform looking down at a swimmer. So a lifeguard is sitting on a platform looking down at a swimmer. So my eyes are looking downwards. In the water. When sitting on a platform, the lifeguard's eyes are 10 feet above the water. So here is the water, and the lifeguard's eyes are 10 feet above. The swimmer is 15 from the base of the platform. What is the angle of depression from the lifeguard to the swimmer? I know I'm drawing these triangles kind of offhand. Maybe I should have been describing it a bit more, but I'm just describing real life, right? I mean, the lifeguard's not looking up at the swimmer. The lifeguard wouldn't be above the swimmer, right? None of that makes sense, right? I'm looking down towards the swimmer who is away from me, right? So I'm just drawing a drawing that just makes sense in reality, right? It's not going to be anything else, right? I'm not looking up. I mean, technically, I suppose you could have drawn it this way, right? You could have said the lifeguard was over here looking down towards the swimmer. But in the end, I mean, you're drawing the same triangle, right? It's just reflected. So just draw reality. Don't get stressed and just draw real life, okay? So what is the angle of depression? So take note of the picture here. Angle of depression is not this angle. Angle of depression is if we were to look straight ahead, that's 0 degrees. So how far are we tilting our head downwards? So what we're looking for is this angle, not that one. Does that make sense? Because looking straight ahead is 0. Looking straight down is not 0, right? I don't want to measure how far I'm looking up. I want to say, okay, if I'm looking dead ahead, how far am I looking down? And that might be thinking, well, how do I figure out that angle? Because that's not a part of the triangle. Well, this, do you see what I'm seeing? This is 2 parallel lines. My eyesight, when looking straight ahead, is looking straight across the water. They are parallel. I know you love it when old stuff comes back up, don't you? These are alternate interior angles. So if I can solve for this angle, well, then I'm solving for this angle at the same time because they're the same. Because they're the same. All right? So tell me, why don't you just figure that out? What is the measure of this angle, which means the measure of that? To your calculator and solve. Couple of options on the screen. Hopefully you did it, right? This is opposite. This is adjacent to this angle. So tangent once again. So inverse tangent of 10 over 15. What is that? 33.7 degrees. All right, last one. We're at the 20-minute mark. We'll make that the last question. Thanks for answering the questions. If you'd like to see one more example, you can. If you're feeling good, you've answered all the questions, so you've got full credit for the video. But if you'd like to see one more, I'm continuing on. Rashid is building a shelf that folds down from the wall. When it is lowered, the shelf will extend 14 inches from the wall. So Rashid is building a shelf that folds down. So here's a wall, and the shelf folds down from the wall. I'm imagining a shelf that's like, it's being, well, also I kind of stopped mid-sentence, and will be supported by a this, right? It's sort of like those beds that sort of fold down from the wall, right? You know what I'm saying? So imagine, those beds, and then it drops down, right? Well, it's not a bed, it's a shelf. So here's the wall, and then the shelf sticks out, and it's being supported by a chain. Right? I'm drawing like a little chain link thing, right? So that's supporting it. It's like attached to the wall, and then this is the end of the shelf, right? And this is a chain that's like supporting it. Because if it wasn't there, the shelf is just going to fall all the way down, right? If you put something on it, it needs support, right? So it's supported by the chain. To the nearest tenth of an inch, well, let's see. The shelf will extend 14 inches from the wall, supported by a 17-inch chain. How far above the shelf should the chain be attached to the wall? So how far above, so this distance right here, let's call it x, right? How far above the shelf should the chain be attached, right? It's attaching up there. And to the nearest degree, what angle will the chain make with the shelf and the wall when the shelf is folded down? So basically it's saying what angle will be formed with the chain in the shelf and the chain in the wall, right? Chain in the shelf and the wall. So these two angles here. Let's figure it all out. Well, I can find the angles pretty easily, right? If I'm trying to find this angle, this is the adjacent side and 17 is the hypotenuse. Let's figure it out, all right? So we're going to, if that's cosine, so inverse cosine of 14 over 17, which is, not going to bother showing my screen this time, just going to plug it in real quick. So that bottom angle, oops, I don't know where my inverse went, but it disappeared. 14 divided by 17, 34.6. So if that's 34.6 degrees, sorry, I'm getting a little sloppy, it's because I'm rushing. Well, subtract it from 180, right, to find the other angle, 55.4. Well, 180 minus 90 minus 34.6. And you get 55.4 for that other angle. What's the length of the third side? Well, if you know 2 out of the 3 sides, you can just use the Pythagorean Theorem. X squared plus 14 squared equals 17 squared. X squared equals 17 squared minus 14 squared. You can't do 17 minus 14. You have to square them first. You get 289. And square the 14. You get 196. And then you can subtract. And I got 93. So when I take the square root, the approximate distance is 9.6. Lovely. Thanks for sticking around if you watched that final example. That's all I got to say. Thank you for watching and have a great day.